Catia 3D Experience enables you to reuse existing components so you don't have to redesign from scratch, thanks to the Catia Tooling Design app. Let's see how this works. Catia enables you to evolve a previous design without compromising the original model, which could speed up your assembly design and your productivity. In this example, we need to add a front wheel with a brake disc to the front fork. Let's imagine you want to reuse parts of an existing wheel and adapt it to your current projects. Since the new one has a different braking system, there are two options: designing it from scratch or modifying the one you already have, which is way faster. In collaborative lifecycle application, the Duplicate Advanced function is a smart way of choosing elements to duplicate. The process is similar to that of assembly symmetry, with a colored preview in the work duplication. From the panel on the top of the screen, you can see that when a part is colored in blue, it means it's going to be reused. In green, it's meant to be duplicated. And when the part becomes transparent, it's to be excluded. As a result, the wheel rim has been duplicated, reusing the bearings and the tire, but without the brake disc. Therefore, any change in the wheel rim will not affect the previous model. We save you time by allowing you to easily reuse and evolve data from previous projects. Also, it reduces costs and improves quality by reusing existing assets and standards. We obtain a new wheel by reusing a certain number of components. We now want to add an existing brake disc assembly. Let's search for it in the database. To complete this new version, existing brake discs will be inserted using the Tooling Design application. The first step is to declare the subassembly as a tooling component to be inserted. The tooling definition command is launched. As you can see, impacted elements are detected during the tooling definition, which means you have some assembly features already applied on this product. It will automatically impact the receiving part of this tooling component. It's also possible to enrich the tooling definition by modifying the type of component. On the previous wheel, tooling anchors, or interfaces, were set up. We insert the brake disc assembly in the front wheel product using the component placement command. Select the receiving part, the red rim in this case, the interface to populate, 2 possible anchors are available, and the component to insert from your current session or search results. In one click, all the available anchors have been automatically used. You may only instantiate an element compatible with the selected interface or anchor. It prevents unwanted manipulations and mistakes in assembly. The insertion even took into account the impacting elements directly affecting the geometry of the receiving part and creating corresponding holes. Catia 3D Experience speeds up assembly design by reusing smart and adaptive tooling components. Plus, we receive and manage the associated impacts at the assembly level. The Save with Options command adds an interesting PLM touch to the user interface. First, a color code indicates in 3D the current status of the elements under the saving process. New components are colored in blue, the modified ones in yellow, and the ones not changed in white. You can create new revisions and also manage the maturity of components. For instance, use the frozen status to prevent anyone from modifying the part, which is great if you're waiting for a review. All of that during the saving process. No need to be on the web platform or on another application to manage your product lifecycle. Catia 3D Experience allows you to know the progress of your work at any time and share the evolution of your product, as well as its revisions and status with people you are working with. The last task performed in the new wheel component is to include it in the front fork main assembly. The robot helps us to easily reposition new elements in the 3D space. You can now connect two components using axis systems. After indicating the required kinematic joint, you just have to select the two axis systems to create the engineering connection. As you can see, assembly constraints and kinematic joints are now created at the same time through one function. The design is almost done, but using material view mode, you can see that the material is missing on the rim, the red part. An easy way to apply a material is to pick one from another part and apply the same material reference on the other parts. No need to search for it in the database. Finally, the last step is to create a mechanism for the front fork in order to prepare the kinematic simulation of the motorbike. This can be done in the Mechanical Systems Design application. Now, launch the mechanism player to see the wheel in rotation, which will take into account the engineering connections and the degrees of freedom. You can define kinematics earlier and throughout the design process, and create complex mechanical systems from elementary mechanisms.